So we've talked about bearing in terms of sea travel and in surveying. Now let's talk about bearings with respect to air navigation. In air navigation, bearings are measured in degrees clockwise from due north. So, for example, if we were given a bearing of 60 degrees for flying an airplane, we would start with the direction of due north and rotate clockwise through an angle of 60 degrees. This would be the direction of our travel. Similarly, if we had a bearing of 225 degrees, we start with our reference of due north, rotate through an angle of 225 degrees in the clockwise direction, and that would give us the direction of our travel. Or 300 degrees, again, always starting with a reference of due north and always rotating clockwise, in this case through an angle of 300 degrees to give us our direction of travel. Okay, and so this is how bearings are measured when we are talking about air navigation. Let's put it to use in a word problem. An airplane is 554 miles north and 709 miles east of an airport. At what bearing should the pilot direct the plane to fly directly to the airport? All right, so let's start off with drawing a picture. Here I have my airplane. Here I have my airport. I know that the plane is 554 miles north of the airport and 709 miles to the east of the airport. At what bearing should the pilot direct the plane to fly directly to the airport? Well, if I want to fly directly to the airport, that's along this green path, we can start off by finding this angle up here. All right, and notice that in drawing our picture, we generated another right triangle. A lot of these are related to right triangle trigonometry. And with respect to our angle theta here, we are dealing with the opposite and the adjacent side of this right triangle. Well, which trig function relates opposite and adjacent sides of right triangles? That would be tangent. And so we could say that the tangent of the angle theta is equal to 709 divided by 554, opposite over adjacent. Well, in order to find this angle, we are going to have to use inverse trig. Remember, inverse trigonometry gives us angles. And so we could take the inverse tangent of each side of this equation, and doing so would give us theta is equal to the inverse tangent of 709 divided by 554. Plugging this into our calculator, again, we hit second tangent, then 709 divided by 554. With our calculator in degree mode, we get theta is approximately 52 degrees. So we have our angle. Now we have to determine the bearing. Remember that bearings in airplane navigation are measured clockwise from due north. All right, well, if I draw out my cardinal directions, due north being up here, notice that in order to get my bearing, I would have to add 180 degrees to our 52 degree angle. 52 degrees plus 180 degrees gives us a bearing of 232 degrees. There is our final answer. All right, so again, bearings with air travel, a little bit different. Instead of giving a north-south reference, we are always going to be traveling through an angle with respect from due north and rotating in the clockwise direction. In this case, we are 232 degrees in the clockwise direction from due north. Our bearing of 232 degrees will direct us back to the airport.